So we just talked about horizontal dilation. Now we're going to talk about vertical dilation. And just as before, we're going to use the parent function of x squared. This time we're going to put our dilation factor outside all the functional steps. So we'll again use 2 as the multiplier. Now realize this could be presented as a y divided by 2, but we've multiplied both sides by 2 now. We have y alone on the left side again, and now we have 2 multiplied by the entirety of the function on the right side, the original parent function of x squared. So like before, we're going to take a look at the t-tables before we start into the presentation of the curves, and we'll start with the same domain, -4, -3, and so on. We see the points generated, and that is the familiar curve to us, again in purple. All right, now for our second function, 2 times the quantity of x squared, again, looking at the t-table that generates. Now we're not going to modify the domain this time like we did before. It won't have the same productive outcome, and in fact you'll see this first point doesn't even plot. I don't think the second one even will plot when we're using the same domain as the parent function. But once we get into the -2, -1, 0 through 4, we do begin to see that curve. And unlike what we saw in the horizontal dilation, we're seeing a vertical stretching. So in some ways on the x-axis it looks narrower, but really what we're doing is we're stretching this dilation in the vertical on the y-axis. So there's your t-table, there's your curve now in orange, and you can see that stretch. And again, what you see now is the output that we used to get from x squared alone is now doubled. So x squared output a +1 for us, or +1 squared output a +1. It now outputs twice that due to that vertical dilation factor applied to the entirety of the function, not just to the x portion of the function. So you can see the position of that dilation factor is what tells us whether it's a vertical dilation or a horizontal dilation.